Salam and good day everyone. So we move on to the next revision, topic 5, functions and graph. As you can see in the revision set 1, 2 and 3, the function and graph question were asked in question 3 and 4, section B. For revision set 1, question 3A, given the function to you, and the first question, it asks you to determine the inverse function. Here we are using the properties, which is f inverse x is equals to x, and we composite the f inverse inside the fx function, so we get something like this, and we arrange back the equation so that we get f inverse x as our subject here. You will get 3 marks for getting f inverse x. Next one, it asks you to determine whether f inverse x that you get just now is a one-to-one function. So there are two ways of showing there are two ways of determining the one-to-one function. It's either using the algebraic method or using the graphical method of horizontal line test. So it's easier if we use the algebraic method like this. And then you get x1 is equals to x2. So we say that f inverse x is a one-to-one function. For question 3b, it asks you to find hx if given gx equals to e to the power of x plus 1 and hgx is equals to x plus 1. Whenever we get a question like this, always write back the information given. So I write back gx is equals to ex plus 1 and hgx is equals to x plus 1. So as we can see, hgx is also equals to h ex plus 1 because gx is ex plus 1. However, we need hx. So we will let y equals to ex plus 1. And then we search what is the value of x. So we're making x as the subject. Since we let y equals to ex plus 1 and earlier we have h ex plus 1 is equals to x plus 1, we can write hash y is equals to x plus 1, where x is also ln y minus 1 that we get from letting y equals to ex plus 1 just now. And then we arrange back the equation and then we get ln y. But remember, we don't want hy, we want hx. So we change back to hx is equals to ln x. If you confuse with this question, you may go to the lecture note of chapter 5 where we have an exercise and also example on this question. Question 3 just now will ask about composite function. Question 4 from set 1 here is asking about the inverse function. It says determine the inverse function of f, hence sketch the graph of f and f inverse. So we find the f inverse as usual. So this question, I don't use the property like just now. We use the letting f inverse x is equals to y and then finding fy and then we get the f inverse x. Okay, but we get two values because we are having a quadratic function. But remember, it gives you the value of x must be more than or equals to 2. So that is why we omit the 2 minus square root 1 minus x. Okay, but before you omit that, make sure your answer have this one, 2 plus minus. Otherwise, you won't get the full mark for the working of getting f inverse. Okay, always remember, if you have a square root, then if you have a square and then you make it a square root, you will definitely get plus minus. But then we reject the 2 minus 1 because it is less than 2. We want it, the value of x given to you must be more than or equals to 2. That's why we take the positive part only. And as you know, the inverse function cannot have two values. Otherwise, it will be a not one-to-one function. Anyway, then we sketch the graph of f and f inverse on the same axis. You must be very careful because this is a quadratic graph. This is an upside down punya graph. So we draw like this. But remember, it's just one side, which is the x more than or equals to 2. It's not a complete U graph. It's just a half U graph. Why? Because it's given to you x must be more than or equals to 2. If you draw a complete U graph, it is wrong because it's not a one-to-one function. Then it won't have any inverse. So that's why this question, it only asks for x more than or equals to 2. So on the same axis, we are going to draw its inverse. So this is your f and this is your f inverse, where we are reflecting it by using the line y equals to x. Is it necessary to draw the line y equals to x? The answer is yes. And the graph must be scaled correctly. Then you will get the full mark for the graph. Next one, we move on to set 2, question 3, section B. It's given to you gx and g inverse, and it asks you to find the constant of a, b, and c. So this is an unusual question because usually it asks you to find the inverse. But then this question gives you the inverse already, but then it asks you to find the unknown inside the function. So what we need to do is to use the properties of g inverse x is equals to x here. And then we work it out to get something like this, to get your inverse value. So we just compare the inverse that you get with the inverse that you have already from the question. Then you will get a equals to -4, b equals to -1, and c equals to 1. Next question, question 4 from the same set, set 2. It gives you a function hx which equals to fx and gx. So this is just a piecewise function which we can write like this. And it asks you to sketch hx and state its domain and range for hx. So we are going to sketch the graph like this. And as you can see from here, the domain, it's obviously -infinity to 1, union 2 to infinity, because we have two functions for hx, and you cannot be wrong for the domain. And how about the range? You can directly see the range from here. From your graph, it's -infinity to infinity. Next question is just ask you to show that hx is not a one-to-one function. So using your graph just now, remember as I said, one-to-one function, you can use the horizontal line test, or you can also use algebraic method. But since we already have the graph, so it's easier for us to use the horizontal line test. So it is shown that hx is not a one-to-one function. In the next set, set 3, question 3, it asks you to state the domain of f and gx. So this is very easy since this is just a polynomial graph, so its domain is negative infinity to infinity, and gx here we have a rational function. We just see the denominator, x cannot equals to -1, so that's why the domain is negative infinity to -1 union -1 to infinity, which you cannot be wrong for a question like this because it's very easy. And then it says obtain fgx and gfx. Okay, this is just a composite function, so it's very easy to do. You will get something like this for fgk and gfk. And then it says hence determine the constant value of k where f of g is equals to g of k. So we just equate whatever we have here just now to get the value of k. And the value of k is 5/4. This is a very easy question and you cannot be wrong for this. The next one from set 3, question 4, it asks you to evaluate f -3. So the trick here is to choose which function to use for f -3. So -3 lies inside the first function. So we substitute -3 inside negative modulus x plus 2, then you will get -1. And then it says sketch the graph of fx. So this is a piecewise function, so you have to be very careful with its interval. You should get something like this. And then it says based on the graph, determine the point of x and y intercept. So it asks you for the point, so you must give in the coordinate form x and y. The x-intercept is -3, 0 here, and the y-intercept is 0, 3, it's here. So x-intercept is the pintasan x, y-intercept is the pintasan y. So this is also an easy question. And then it says hence find the domain and range of f. So you just look at your graph, or you just look at the value of x from your function here. It's obviously the domain is from -5 to infinity. And also the range, we can see that from your graph, -3 to 0, union 1 to infinity, because between 0 and 1 you don't have any graph, so that's why you have to put union here. It's not -3 to infinity.